And as promised, we're going to go over the engine parts. And what I could tell you is there's quite a few people that got it all right because there's a lot of 34s up there. So there's quite a few people that have already figured all of these out. So let's go through them together. So if I start and if I find number one here, what is number one?
Intake manifold.
No.
Cylinder head.
Cylinder head.
Cylinder head.
Cylinder head. And number two?
Gasket.
Yeah, the gasket.
Yeah, the cylinder head gasket or head gasket. Number three?
Valve covers.
Valve covers. And number four, everyone should have that because I gave it to you already.
Yeah. Valley gasket.
Valley gasket. And number five?
Valve cover gasket.
Valve cover gasket. And then we move over to number six, which is a
Valve.
And there is no number seven. Number eight is a
Valve stem seals.
valve stem seal. Number nine,
Spring.
yeah, valve spring.
Spring.
Number 10,
Valve retaining washers.
yep, valve spring washer or valve retaining washer. And number 11,
Valve. No.
Valve keepers.
valve keepers. And number 12,
The adjustment bucket.
yep, the adjustment bucket. So shim and bucket or adjustment bucket. And that's why I did the matching game on this, is because that way, if you know what it is, you should be able to get real close to the thing. So that way we're not splitting hairs or I'm not chasing misspellings. So that's number 12. So now we come over to, where's 13? There's 14. Where's 13?
13. What's there?
13. What is 13?
Camshaft.
Camshafts. Number 14.
14 front crank seal.
Front crank seal. Very
Good,
good.
Lorna.
Oil seal.
Number 15.
Shaft seal.
Belt
Camshaft seal.
Camshaft seal.
Yep. Number 16.
Timing belt.
crankshaft sprocket. Crankshaft
That's the
sprocket.
that's the timing cover gasket.
Timing covered gasket. And you know that one all too well, Christopher, because you saw that on the Honda you took apart.
Oh yeah, that's right.
Yeah, I had to actually, when I originally did the head gasket the first time, I noticed the previous owner or whoever worked on it, there was a bunch of missing little ear loops that the
Yep.
thing, they were just all broken off and it was hanging on by like one. So I just went and bought a new one from the dealer. It was like $30.
And that's a good call because that can go in and actually damage the belt. So that's a good call. When you have oil leaks or excessive heat, it's not uncommon for those to get warped or the seal in there to get swollen. So, we do replace that separately. Number 17.
Crankshaft.
17 crankshaft.
17, I have
Crankshaft sprocket.
crankshaft sprocket or camshaft sprocket or just sprocket. Number 17, I put crankshaft sprocket. So that is the 17 down here. Unfortunately, they use 17 for the camshafts and 17 for the crankshaft. Maybe I should just change that to sprocket.
Rocket.
But crankshaft sprocket is the correct answer. We have it down here, but they use the same number up here. Or maybe I should try to go in and get rid of it or something. I don't know. I need to try to do something with that because they use the same number in two places, which is confusing. So 17, 18 is a
Timing belt.
timing belt. Number 19,
Timing
And
belt.
Timing
Yeah.
belt
timing
tensioner.
belt tensioner. Number 20,
Timing belt idler puller.
timing belt idler
Yes.
pulley. And you see the difference. One has the spring and the pivot to tension. The other one is just a round pulley. Good job. So there's 20. 21 is our
Piston ring.
piston ring.
ring.
Number 2 is our
piston and wrist
Ring.
pin.
piston and wrist pin. 23 is our
Connecting rod.
connecting rod. And 24 is a
Bearing, connecting the bearing.
Connecting rod bearing. Yep.
Oh, okay. Bearing.
So 24 is the connecting rod bearing. 25 is
Bearing.
Main
main
bearings.
bearings. And 26 is the
Crank
Thrust.
pulley and key.
Bearing.
26 is the thrust bearing.
Okay.
Fast bearing.
And 27 is the
Crankshaft.
Crankshaft and keys.
Key.
Woodruff keys or end keys. Let's see, what do we call it here? 27 crankshaft and keys. Yep. And you see the thrust bearing, main bearings, connecting rod bearing. Okay, so that takes us up to 27 is our crankshaft and key. And then 28 is hiding here somewhere.
It's the rear crank seal.
Oh, 28 rear
28.
crank seal. Yep. Or rear main seal.
Rear main seal.
Rear main seal is another name for the rear crankshaft seal.
Okay.
Remember what I said? We can't just call things one name. It'd be too easy in automotive. We got to have a lot of different names for the same thing. So that's the rear main seal or rear crankshaft seal. 29.
29 is crank pulley and key.
Yep, crank pulley and key. Also might be harmonic balancer, so that's 29. And 29 is crank pulley and key is what we used. It could also be called a harmonic balancer. So 30.
No 30.
No 30. So 31.
Flywheel and ringer.
Where's 31 at?
Flywheel and ringer, sir.
Oh, flywheel and yep, 31 is the flywheel with ring gear. 32?
Oil pump and cover assembly.
No, 32 is the oil pan.
Oil pan.
Oh, oil pan. I mean, oil pan.
I knew that's what you meant.
Yeah, 33, sir.
33 is the oil pump and cover assembly.
Yes. Yes.
And 34,
Oil pickup screen.
oil pickup crane or oil pickup strainer, or sometimes we call it that. And that's everything.
Yes, sir.
And there's nothing here that you guys didn't know collectively.
It were bigger.
This is actually pretty big. This is the size you'd get it in the, if you go look it up in all data. This is from a Toyota Corolla is what this is from.
Oh,
So if I got to look up parts for a Toyota Corolla, this is what I'm looking at for this particular engine. So they are, this is real world here. This is one that I picked up, and believe it or not, I must have spent an hour looking. This is the best one I found. They get worse.
yeah.
from here.
For me, Mr. Brian, it's hard, especially the 8, 10, 11, and 12. It's hard to figure out, so that's why I took 3 times
Yeah.
before I got 34.
Right. And it is hard, but it is in the same order that the slide in the PowerPoint shows you and that the book shows you. So that order doesn't change regardless of car. The only thing that's different is the bucket at the top. Some of them have a bucket and some don't.
Yes.
But yeah, it is hard, but that's also why I give you more than one chance with it, because you know it because you spent the time to learn it by doing it 4 times or 3 times.
What I did is I go back to the picture at Google and then go back again, go back and go back until I figure out.
Yep. Perfect.
Yes, I got 34 out of 34, but it's 3rd time.
Yeah. Well, and again, that's why this is an online exercise and not a quiz, because this is designed to help you learn,
Yeah.
not
The quiz
to
that
assess
I
how
know.
much you know after a 2-hour Zoom meeting.
Yes, the quiz that you given us
Uh-huh.
is like a little bit easy.
Thank you for calling.
Okay.
Yeah, I got perfect for that.
Good.
I just asked you, Mr. Brian, before I got my test, my grade is 102, and then I passed the 2 tests that was yesterday, My grade is only the same.
Yeah, well, again, if you're getting 100%, you do two more things that are 100%, it's not going to raise it. It just keeps it from getting lower. That's the problem when you're at the top. When you're at the top, it's real hard to. I mean, you're already when you're already hitting the ceiling. It's hard to get through the ceiling, right? You
And
know,
I'm just
but
wonder
the goal
why.
is to not drop.
What the fuck?
And
Because it's
I
all
asked,
about percentage. If you got 100%, all doing 100% does is keeps you at 100%. If you get less than 100%, now your grade drops. So that's why your grade didn't go up, is because you were doing great on everything else and you just continue to do great.
Mr. Brian,
Yeah.
so you told Christopher a moment ago that he did a good job by replacing the gasket. I have two gasket questions.
Okay.
A, do you always 100% of the time say replace the gasket if you pull something apart? Because just by the fact that it was there and it was compressed to begin with in order to make a good seal, now you've taken it apart, it's compressed in all the wrong places. And B, technician A says always use some type of RTV sealant or something on both sides of the gasket when you put it together. And technician B says, nah, you don't have to do that, just put it on dry. Who's correct? You like the way I did that last one?
I do like how you did that last one. I'd say they're both wrong. Although some manufacturers do say to install a gasket wrong. I mean, dry. So that does occasionally happen. It's just you don't always do it. You never want to put silicone on both sides of the gasket, because then you have a slippery surface on both sides of the gasket and the gasket will squeeze out. So you only want to put silicone on the one side of the gasket, preferably the side that's on the least precise material. The gasket he replaced, number 16, is actually a reusable gasket, because what it's really is really a dust seal more than it is trying to keep anything in. So if I open up something that the gasket's actually used to keep something in, I'm going to replace it every time. Absolutely. So I don't care if that's a thermostat gasket, a timing cover gasket, a water pump gasket. If you take it off, you should put a new gasket on. They do have some reusable transmission pan gaskets. I still replace them. Even they're a quote unquote reusable gasket. They're great gaskets, but the thing's been there for 10 years and 100,000 miles. And really, you know, on the other hand, if it's a reusable gasket, I just put it together and I got to take it back apart and it hasn't left the shop. Yeah, I'm going to reuse that gasket. It's a reusable gasket. It hasn't gone anywhere. It's got 10 miles on it or whatever. But a normal service life, I'm not even reusing reusable gaskets. And some of these reusable gaskets are $40. But I'm not willing to risk the job on that. I've seen them leak. And again, you got something with plastic and rubber in it that's been there for 10 years, lots of heat and 100,000 miles. Do you really think just because it said reusable that you're going to reuse it? No, of course not. So did I answer that okay for you, Rob?
Well, what I'm hearing that in general, as far as reusing, if it's older, and especially if it's been used to keep some liquid, especially contained, you're just going to do a new one and be safe. The other thing I heard is that you never put a sealant on both sides, but sometimes you'll put it on one side, but not always. Sometimes you'll do dry. I'm not sure how to tell which time is which on that.
It comes down to clearances. So sometimes manufacturer will have machined aluminum pieces that are so precise. They use a very, very thin gasket and don't want any silicone on it. Also, if I'm in a transmission like a valve body gaskets, we use no sealant or anything. They're all put on dry. So there is a lot of times is when you have two machine surfaces with very tight tolerances. Even the oil pump pickup screen that we see here in the picture, 34, where you see a little gasket there, you would install that dry because it's a heavy plate going to a machine surface. So that's designed to go on dry. The whole thing's immersed in oil, but it's designed to go on dry. Putting silicone there, you could actually pull silicone into the pump and create a problem or restrict the opening. So there are times that we do put on gaskets dry. They also have a material called high-tack, and you buy a high-tack spray, and you can use that on one side of those gaskets that are designed to go in dry to hold them in place. And it's basically almost like a sticky paint. And so you'll use that occasionally to put things together not inside a transmission, but like cooling system parts and other parts where it is a real tight tolerance. But you've got too many moving parts and the gasket wants to drop, you use high tack to hold it in place. We normally only use high tack with paper gaskets.
Could you use that stuff with rubber too? If the rubber keeps on coming loose?
No, you're not going to use high tack with rubber. You're only going to use it with paper.
All right.
With rubber, you a lot of times you use a dab of silicone to hold it in place.
All right. Because I have used the high tack on rubber before and it holds it in place. But I don't know what the issue would be
Well,
afterward.
the issue would be is that it can cause a leak because the high tack's not designed to be used with the rubber. And what will happen is it'll actually kind of curl and it'll delaminate basically. And that delamination can cause a change in torque. It can also cause a seepage leak.
All right.
Because
So,
Brian,
two
also,
things
like,
next
if
to each other that aren't stuck. What's that?
I was
you're
gonna say, I
thinking-
noticed also, like, if you purchase like a gasket set online, sometimes they put in lower end, cheaper, like paper gaskets where you would normally have like a metal gasket, like a thermostat housing and stuff like that. They'll put it in there. And I've always went with like OE, you know, in certain areas like that. I know if you go to like the throttle body, somewhere where it's not going to get too much heat, I figure, you know, the paper gaskets are cool up there. But like towards like the engine coolant and stuff like that, I always replace it with the metal one.
Yeah, a lot of manufacturers do use paper for thermostat gaskets, water pump gaskets, timing cover gaskets. Do I like the metal better? And on the other hand, Toyota factory water pump gasket in a lot of cars is a metal with a rubber seal, basically a synthetic rubber seal on the inside that are great. They're technically a reusable gasket, but I never would. But if I order an aftermarket water pump, it comes with a paper gasket that's well inferior to that factory metal and rubber gasket. On the other hand, my pickup truck, my water pump gasket's leaking on it after about 12 years. And it's a paper gasket. That's all they make for it. And it looks like I'm seeping a little bit at my timing cover too. So I need to order parts for my truck and take my water pump and timing cover off and clean everything, reseal it. My water pump's also leaking through the weep hole. Like I said, it's been 12 years since I did it. But I just got my Jeep out of the garage, and apparently I need to get my truck in the garage and spend, you know, some time working on it, because that's a 5-hour job. So I'll be spending a little time on that. I'll probably shoot some video on it, just because it's not often we have a timing chain apart and I can show the timing chain and all that stuff with it. But no,
What brand of water pump would you use for Toyota? Asian brand or the
What's
original
that?
Toyota OEM?
What was that? What
Water
kind of
pump.
water pump would I use?
Yeah.
I use the Asans a lot, which is OE for Toyota. That just makes them for Toyota.
Yeah, that's what I got. I even got the thermostat.
Yep.
The same.
So Brian,
Yes.
good morning.
Good morning.
On the native seats, I have a question. So I look at the videos and it doesn't really give us the answer for all the spots that we have to fill up. Is that okay, or
What's that?
Like-
Oh, on the lab sheets, yeah. So you can tell the difference. Like when you get to the power balance lab sheet, it's really written for the video. The other ones that I use from the lab, the first of them have some lines in them that don't apply to the video you're seeing. So fill out what's in the video and go from there. So good question. Also,
Okay.
I had someone ask me a question about number 7 and 30, and I did not include them in the exercise. So the reason why I didn't include number 7 is also a valve. Obviously, one is an intake valve and one is an exhaust valve. And without knowing which manifold is on which side, and since the manifolds are not shown here, it would be impossible for someone to know what side's the intake and what side's the exhaust. So that's why I just used one of them and put valve for 6 and 7. I didn't include 30 because 30 basically is 31 plus the Woodruff key. So I thought that I had to choose either between 30 or 31. And I went with 31 because I thought it was a clearer thing that people could call out. And I didn't want to do 30 and 31 because then people are like, well, what's the difference? And I guess I could have done 31 and then 30. This is a flywheel with Woodruff key. But that's why I chose not to, but I still made it worth 34 points. So the computer rounds. That's why, how can you have 34 points when you aren't asking 34 things? Well, it's the magic of math. So hopefully,
Well, like you said, it's a real world experience. So just it's similar to like 23 and 24, because
right.
23 it is the assembly, the connecting rod assembly, and then
Right.
24 is the connecting rod bearing.
Yeah.
So it's just all about being attentive and paying attention to what is, it's really.
Yeah, no, absolutely. But like I said, there's no way for anyone, including myself, to tell you which valve is which without seeing the manifolds. So if it showed the manifolds in the picture and it showed an exhaust manifold and intake manifold in the picture, I would not have hesitated to call out the intake and exhaust valve separately. But as it is, I thought it was totally unfair to do that, even though I could obviously look up on the backside and see which is which. And so that's precisely why I didn't. And so that's but that's why I didn't include those two and why we decided not to. But I did separate out 23 from 24 because I thought it was important that we know what's a bearing and what's a connecting rod assembly. So that's why I went ahead and did that. You're right, that is real, because that's a great example. Do I need to buy the whole connecting rod or do I just need the bearing? And if they had called out 30 as a separate for just that Woodruff key, I'd have left it in. Because there is times you need just a Woodruff key. Okay, so I'm going to stop this share and we're going to do a new share. And so today and tomorrow we're going to go through lubrication. Lubrication is always fun. Usually we get some good conversations in it. I do have a article on lubrication, so I'm going to open up that discussion today after class. So the discussion is an article about oils, and you guys can read and comment on. So that is the discussion for this module. So I will get that opened up today. I meant to do it yesterday and I forgot. I got sidetracked. So it is on my plate today. And so lubrication, the engine's lifeblood. So if I don't have lubrication, the engine doesn't run very long. We're talking a minute. So this really is the engine's lifeblood. There's a lot of different kinds of oils. We are going to talk about oil. I really don't get into talk about how we make oil or how we refine it. The last book we used, GW, spent almost half the chapter talking about how you refine oil. Well, I'm not looking to get in the refinery business. So, although that's might be interesting to some people, it really doesn't have anything to do with how the car works or the main components. So I'm going to talk a little bit about lubrication theory, and lubrication is used to counteract the forces of friction. Anytime two components are moved against each other, friction is created. Friction equals heat and wear. So I don't care if it's your two hands and you rub your hands together really fast, they're going to get hot. And if you keep doing it, it's going to hurt, right? Now, if I put some water on my hands and do it, I'm going to be able to do it longer until the water finally evaporates, and eventually I'll get, more heat. And again, and then maybe if I put some oil in there, then I could do it longer, right? Because oil has it's more slippery, as we say, right? It's going to reduce the friction between my hands. I'm going to have a harder time generating that heat. But what I'm going to do is I'm going to make the oil hot. So instead of my hands getting hot, now the oil's getting hot. So friction is heat. So what we want to do is we want to change the coefficient of friction. So if I'm stopping a car, I need a really good coefficient of friction, right? Because if I am on ice and I hit the brakes, even if I stop turning the wheels, the car is still going because I have a very low coefficient of friction. Or if I'm on sand, because we have sand here, we don't have any ice in San Diego County. Again, a low coefficient of friction. Compare that with dry concrete and I hit the brakes. Now I've got a really good coefficient of friction and I'm going to stop really well. So, and that has to do with the coefficient of friction on my tires. So what's really good for the stopping the car is not so good for running the car. So inside the engine, I want the lowest coefficient of friction I can get. So friction, the force that opposes movement between any two objects in contact with each other, and the amount of friction is going to vary by the type of material, the surface finish on the materials, the amount of pressure holding the two objects together, and the relative amount of movement between the objects. In other words, is it moving like this or is it moving like this, right? The more movement, the more friction. If it's just doing this, not as much friction. So when we look at friction, it takes force to pull block A along surface B. The force which counters the pulling force is called friction. So if I try to pull A along B, I might be able to pull it with 100 pounds, but what if that's 1,000 pounds? Is that going to be harder to push? How about if I put a layer of ice between A and B? Is it going to be easy to push now?
Yeah.
Okay. So I could probably push 1,000 pounds on ice where I'm not going to push 1,000 pounds on dry concrete, right? On the other hand, instead of having this big block of A that's square, what if I put two skinny runners on it? Would it pull easier? Even though it has the same weight? Would it be
In
easier to
theory.
move? Yeah.
What you're gonna put again, Mr. Brian? What is it
I
again?
said, instead of having this big square with the weight on it, what if I put two narrow pieces on the bottom of the square and that's the only part that's contacting B? Would it be easier to pull that?
Yes.
Yeah, just like a sled, right? So
Yes.
why? I'm still moving the same weight, but I've reduced the coefficient of friction because there's less surface area. So that's why if you have something that's really heavy that you can't move, but you put it up on two pieces of wood, now you can slide it. A couple of things happen. Less surface area, as well as the coefficient of friction of wood is different than the coefficient of friction of concrete or asphalt. So there's all kinds of things you can do. For example, I just had to unload a thing of roof tiles out of my trailer, and it's, you know, a couple thousand pounds. So I had to drag it back so I could get it with a forklift. Well, instead of dragging it flat, I tilt it up and then drag it. So the only part that's contacting is the back. Now I can very easily move this 2,000 pounds because I've reduced the coefficient of friction. If I moved it flat, there's more friction.
What'd you drag it with?
My forklift, which is apparently developed an oil leak because I went down to the garage and there's a puddle of oil under it. So I think I may have lost the front seal on the engine, which is really bad because on a forklift, things are built around the engine. You actually have to split the forklift in half to get to the engine. So it's a major. So if I need to do that, that'll be a major repair. I'll probably put a new clutch in it, fix the parking brake, do a whole bunch of stuff, but it's a major disassembly project on like a late 1940s, early 50s forklift.
So you need us to recommend a good mechanic for you.
Yeah, I might. I have a buddy of mine that did forklifts for 7 years. He works on cars now. Actually, he was a student of mine and I'd gotten him a job and we've stayed friends for many years now. And he used to do forklifts. So if I get in a jam on how something comes apart, I can get him to come over and give me some pointers. Plus I got a factory manual, so I'm all set.
How long would it take you to pull one apart?
Don't know, haven't done it. And you're talking something that's been together for 70 years. Nothing comes apart like it should.
Hopefully you don't break bolts.
Not a big deal. If you do, you put in new bolts.
Yeah, but they're hard to find bolts for.
No, not really. It's all standard thread. So as we look at the contact surfaces, in this case of the two blocks under a microscope, we see a series of sharp points and grooves and other imperfection regardless of how smooth they're polished. So even on the engine, even inside the engine, even though things can be very, very smooth, on a microscopic level, there is still some of this roughness. And that roughness has to be there in order for it to capture the oil so we can reduce friction. That also gives us that wear layer as we wear through that roughness. And that's true inside a cylinder. That's true in bearings.
Hello.
Yeah. Oh, Rudy's on the phone. I'm going to mute him then. So friction equals wear and heat. Pressure plus movement equals wear. Bearing pressure in a normal engine can reach 1,000 pounds per square inch. Heat produced by friction, just like rubbing two sticks together, you can start a fire. So there's two types of friction. One is dry friction, where both rubbing parts are clean and free of materials. So that comes into, we have certain synthetics and nylons that we actually don't use a lubricant and they're dry. Those are normally low speed applications. So we do have some dry friction things. You might have those in your windows or other things where you have a piece of nylon and it's dry friction. You don't put anything on it. And again, you're not moving very far. And then we have wet friction, which is what we use inside the engine. This is where rubbing parts and other materials are placed between them. So what we're doing by doing this is by putting oil between two parts, and either both of these parts are moving or one of these parts is moving. We've now, instead of making the other part the wear item, we've made the oil the wear item. So that we're actually, the oil now becomes the friction surface. So the oil is the part that's getting the wear instead of the metal products. And that's what allows us to have engines that last for hundreds of thousands of miles. And that's also why not changing the oil or using the wrong oil greatly diminishes the lifespan of an engine, because that oil is actually now our friction surface. So there's two types of bearings. One is a friction bearing. This is two smooth surfaces sliding against each other where we have oil or some lubricant in between them. We're going to go with oil since we're talking about engines. Then you have anti-friction bearings, which utilizes balls or rollers between the moving parts. One or more anti-friction bearings are used in most every part of the vehicle. So this is like a wheel bearing, right? A wheel bearing lasts for a long time. You can pack it with grease. It's good to go. That's because it's an anti-friction bearing. So the balls or rollers in it are constantly moving. They're not sitting at one spot, and the grease is still there to lubricate and cool. A friction bearing, nothing in the bearing is moving, and therefore it would just be like rubbing two things on each other. So we need to put something between them. So as one moves, the other one doesn't. The oil in between them is what's actually feeling that force and is able to dissipate that heat. So one of the things oil does is lubricates. The other thing it does is gets rid of the heat that's created from friction. So if I look here at a friction bearing, we have a layer of oil between the shaft and the housing. If I look at an anti-friction ball or roller bearing, now I have a shaft, I have all these balls or rollers, and then I have the housing. So the balls or rollers are constantly moving, so the friction's not staying in one spot. So that also helps dissipate heat in the grease, but also helps them last a lot longer. Where the one on the left, the friction bearing, is completely dependent on that oil being there or that fluid being there. So if that oil is not there, this bearing will last a minute, 2 minutes. I mean, you're done very, very quickly. Here's another picture. This is out of the book. It talks about the lubricating oil. And the main function of the oil is it lubricates, cushions, cools, cleans, and seals. So it does all these things to make sure that it's working properly. So seals, you think, wait a minute, I'm trying to seal the oil in. How does oil seal? Well, when I fill a surface area, and if that surface area is real thin, I use the correct thickness of oil under the correct pressure. Now I'm able to fill that area with oil and keep it full. If my oil's too thin, I'm going to have a harder time filling it. If the clearance is too big, I'm not going to be able to keep it full. So, but the oil actually does seal those areas up because of its viscosity, its thickness.
To slide easily, Mr. Brian?
What's that?
Slide easily.
I'm sorry, I'm not picking up what you're saying.
To slide easily when you put oil?
Yeah, it slides easily with oil in it. That's the whole reason why we use the oil, so it slides nice and easy. Super easy.
Don't get heat.
Well, the oil is going to get heat, but what the oil does is the oil takes that heat and moves it, because heat is energy, right? So with
Yes,
friction,
energy.
that's energy. I got to do something with it. It just can't go away. So we're going to put it in the oil as heat energy. And then I'm going to take that oil and I might exchange it with the cooling system for the cooling system to get rid of it. I may use a separate oil cooler where I exchange it with the air for the air to get rid of it. I also may have, if I have an aluminum oil pan, I may have fins in the oil pan that allow the air to go past the oil pan and the aluminum dissipates the heat. Or I may have a thin metal oil pan on the bottom, which again allows me to dissipate the heat. So we want to get rid of some of that heat because heat kills. It also works as a cleaning agent. So oil, as of 34 years ago, 35 years ago, was over 51% additives. So sometimes you'll hear people say, gee, I want an oil without any additives. No, you don't. We used that back on Model A's and Model T's, and you were taking those engines apart at 10,000 miles. So you don't want that.
Mr. Brian, when you use the word oil, you're also including grease in that definition. Is that right?
No, right now I'm really only including oil specifically because I'm talking about friction bearings.
Because
I would use grease in a non-friction bearing, and yeah, at that point the grease would be dissipating the heat and lubricating.
Right. When you were talking about roller bearings, and I was thinking, ball bearings, roller bearings, needle bearings. Then I was thinking grease, but you kept saying oil, so I was assuming that you were using them interchangeably.
No, I didn't mean to. Some things you would use them interchangeably. For example, I can have a ball bearing or a roller bearing in a transmission that's lubricated by oil instead of grease, so I can certainly use that there. But again, that's a anti-friction bearing. Once we get to a friction bearing, we're only going to be using oil. But in an anti-friction bearing, I could use oil or grease depending on how I design the system. So it would be interchangeable in that case.
Thank you.
You bet. And here I'm talking specifically about us using oil in the engine to get rid of heat. So not only are we lubricating, but we're getting rid of that heat. And some common additives that we see are extreme pressure additives because our oil systems run at higher pressure than they did 100 years ago. Oxidation inhibitors. Oxidation creates corrosion. So we also have corrosion inhibitors. If oil oxidizes, it tends to get really thick, almost like a paste. And you'll see that occasionally in a car that hasn't had the oil changed in a long time and has had moisture introduced to it. Defoaming agents, because we have a lot of moving parts inside the engine and I want the oil to stay liquid. I don't want it to get frothy and foam because that would put air into the system, which would mean that I would no longer have consistent pressure in my friction bearing, which means I could have damage to the bearing. Detergents for cleaning. So a big part of what this is cleaning. Some dispersants, pour point dispersants. So this helps with its ability to flow, and viscosity index improver. And what this is I'm going to get into viscosity. Normally, when something is cold, it's thick. And when something is hot, it's thin, right? So I know that with cooking oil. Last night I poured some olive oil into a pan and I turned it on and I knew it was ready to add the other ingredients when I moved it around the pan, and it definitely moves different than it did when I poured it out of the container. Because it's thinner, right? I mean, it's gotten thinner with heat. With engine oil, we use viscosity index improvers so the opposite happens. So that the oil is actually thinner cold, but has the characteristics of being thicker hot. And so that's very different compared to what we normally see with things. So that's done with additives, and that's how we came up with multi-weight oils, where it has the characteristics of a thin oil, cold, so I can start the engine, less drag, but characteristics of a thicker oil, hot, so it protects the hot engine. And those are our multi-viscosity oils, and we'll get more into that shortly. So modern oils prevent formation of acids, carbon, lacquer, and gum deposits. Vital that the detergent additives and oil hold these impurities in suspension until they can be trapped by the filter. Now, filters only trap down to about 20 micron. which is pretty small. I mean, it's smaller than the diameter of a human hair, which is, if I remember correctly, is 50 to 70 micron around. So you are talking small pieces that it does catch. However, it doesn't catch everything. And so we use a lot of these additives in here to suspend these contaminants. And that one of the reasons why we change oil, one of the biggest reasons why we change oil, is not that the oil on a modern car is worn out, although it may be depending on the type of oil you're using and the mileage, but is to get those contaminants out of the engine. So if you notice, oil starts out where you can see through it. It's really a light color, maybe a yellow or yellowish clear. And when it's old, it becomes brown and eventually black. Well, that happens for a couple reasons. One, it can be because it got overheated and burned, right? We can always burn oil. But more commonly what it is those are the contaminants that are trapped in the oil. So those contaminants are suspended in the oil, so they will be out of the engine when you drain the oil. When I started in this business, when we took an engine apart, it was not uncommon that after we took a valve cover off, we had to use a screwdriver or something or a knife to clear around and dig out all the deposits just so we could find the bolts to hold the head down or to hold things together inside. There was that much of a coating on it. Modern engines, we don't have those issues because of these different additives that are now required. So I said back in 1986, over half of the bottle of oil was additives. Okay. And that's what we call a conventional oil or a non-synthetic oil. We do have synthetic oils also, and I'm going to get into them a little bit later, but even a non-synthetic oil is well over half additives. So modern non-synthetic oil is over 50% additives. True or false? True.
So, in regards to, because I know all oil is pretty much the same, it's just lubricating. The difference between, I wouldn't say regular, but high mileage and non-high mileage would be the different additives, correct? Or
let me address that in a little bit when I get a little bit deeper into the types of oils. The high mileage is really more of a gimmick than it is anything else. I'm sure they do have some different additives in it. They're not really additives that you require necessarily, but it is a huge marketing thing. It's a great niche that they came out with. The reality is your car specifies an oil when it left the factory. On modern engines, I'd say made in the last 20 years since 2000, you should never deviate from that. That's designed for the life of the vehicle, whether it's its first mile or whether it's its 200,000 miles. So my car, I have 195,000 on it, and it uses the same oil today that it did 195,000 miles ago, because that's the oil that is designed to use. And I use a quality oil. So I think, and the big thing is I'm going to step back to another thing you said, oils are all the same. No, they're really not. Oils within a certain category may be similar, not necessarily the same. And even if they meet some standards, they may not meet others, which further separates them. So I could have, and so let me go through the different terms we use in oil, and we're going to come back to this.
Yeah, no worries. And I know they're not identically similar. I meant just like the function's the same. Like they're all.
No, the function in the vehicle is the same. Yes.
And I meant I was assuming that higher mileage meant more additives, for cleaning an engine that's been on the road and in service longer. That was my logic by it. But I know oil, its function is the same in every vehicle. It's just lubricating. You're not getting anything special.
Right. So okay, I'd agree with that. I'm sure the additive package is different, I'm not sure if it's more cleaners or less cleaners on high mileage. Do you, I mean, because there's the old argument, do you really want to clean a high mileage engine? Then you end up with all the sludge or things break loose. So is it, or maybe it's less cleaners on high mileage. Oh, I don't know. It was a great marketing ploy by oil companies to sell oil. And again, we think about high mileage. What is high mileage? And I think that term has changed over the years. There was a time when 70,000 miles was high mileage. If your odometer went past 100,000 miles, it was an event to be celebrated because most cars didn't get that far. Today, I just saw a study over the weekend that I read, and currently the average mileage of a car on the road, this is average, so everything from a brand new car to whatever, average. Any guesses what the average miles on a car is today? Everything from a brand new car to whatever.
Can I give you I don't know, 85 to 105?
Okay, and that would have been a really good guess, and that's actually low. That would have been true 10 years ago.
How about 150?
Not quite 150. It is between foreign and domestic, it's 125. What we're seeing is domestic, it's about 150, and foreign is lower than that. But foreign has more of the fleet. You know, for foreign, I think it was 115 or something like that. But they have more of the fleet, so it leverages that down. But I was really surprised when you look at across the board, the average 125,000 miles. That, and it broke it down by trucks and cars, foreign and domestic. I mean, it was just a quick article on one of the news feeds I get. But I did think it was interesting that the average is 125. That means for everyone with a car with 1,000 miles, there's someone with 249,000.
So it's safe to say we're trending in the right direction.
Depending on who you talk to, yes. And the reason why I say that, if we're looking at longevity, if we're looking at as a consumer, I want my car to last a long time, absolutely. If I am looking at it as someone who my biggest concern is carbon emissions and green energy, it's bad news because I want all brand new cars on the road because they run cleaner than a 12-year-old car or a 20-year-old car.
Not so good if you're a car salesman.
Oh yeah, if you're a car salesman, it's bad news too. You want people to turn a car over every 3 years. So it really does vary based on your point of view. I agree with Christopher. I think it's great news. But you are going to hear people say that it's bad news because we can't all ever agree on anything. But that is the other side of the coin, is that if I'm driving my 87 truck, it is polluting more than if I was driving a 2021 truck. And that's true. A 2021 truck is going to pollute less per mile than my old truck does if I'm just looking at what comes out the tailpipe. But what is the environmental impact of crushing my old truck? What's the environmental impact of building a new truck, getting it to me, delivering it, everything else? And I put 1,000 to 3,000 miles a year on my truck. So how long at 1,000 to 3,000 miles a year of better tailpipe emissions would it take to offset the carbon imprint of destruction and assembly? Going all the way down to mining, where's the steel come from to build the truck? Where's the aluminum come from? Where's the synthetic rubbers come from? The oil there. I mean, if you did an honest appraisal of total footprint, which we never do. You know, so like I said, with any discussion, how deep did we go in the discussion? And I'm not here to, you know, push one thing or another. I occasionally get someone who gets really upset that I even question it. My point is we should be asking questions. We should be looking at the whole picture because that's the only way we make good decisions.
Mr. Brian,
Mm-hmm.
is there such a thing as, excuse me, organic oil?
Yeah, actually all regular oil is organic by definition. It comes out of the ground.
And are they used for cars?
Yeah, that's where normal oil comes from. That's where gasoline comes from.
Oh, oh, not for like oiling the engine.
Yep. Yeah, it all comes from the same place. It's boiled out of crude oil, and at different temperatures, different things separate. So gasoline separates out. It's pretty volatile, around 100 degrees Fahrenheit, something like that. Kerosene's around 300. I don't get oil that goes in the engine until we get up somewhere between 600 or 800 degrees in the refinery. So as we heat the oil, we pull different things off of it that we use for different purposes, whether it's kerosene or gasoline or oil for the engine. So we have two different kinds of oil. One is conventional oil. This comes in theory from dead dinosaurs. Okay, that's not the only theory. And you're welcome to, it's the widely accepted theory. It's what we all say. It came from dead dinosaurs. That's where the oil came from. And that very well may be 100% correct. There is another theory, and that's actually gaining some momentum for a few reasons. And it starts with an A. I'm trying to remember it. But basically, the oil comes from rocks, and it's a natural thing, and it's not a finite, because new oil is always being created. And that argument has been further fueled by wells that were tapped out that had no more oil are now found to have oil in them. So there is some discussion on that. So conventional oil processed from crude oil comes down a pipeline or a tanker, and then the crude is broken down into mineral oil, which is then combined with additives to enhance the lubricating quantities. Without additives, it would foam easily, break down quickly, and corrode engine parts. We also have what's called fully synthetic oil, which first appeared in the auto industry in 1972. It was either 72 or 73. The book actually mentions it, AMSOIL, AMSOIL, which is the article I'm going to have you guys read. AMSOIL was the first company to have a synthetic oil approved for use in automobiles. Full disclaimer, I run AMSOIL in my own vehicles and have for years. We also have a semi-synthetic oil, which is a mixture of synthetic and petroleum-based oils. So we see a lot of that out there right now. Synthetic motor oils provide greater lubrication value and heat resistance than petroleum-based oils. Many modern vehicles require synthetic oil. If your oil weight that your car requires starts with a 0, so it's a 020, a 016, that's a synthetic oil. They cannot get a 0 weight oil without being synthetic. There are two different types of synthetics. One is type 3, where they're still using crude oil, and they're kind of mimicking a synthetic, and that's called a base stock. The other is a type 4 or PAO oil, which is a true synthetic artificially made in a laboratory. And that was first used widely in 1940s by Germany. And then that technology has evolved. So true synthetic oil. And again, unfortunately, if I buy a bottle, it says synthetic on it. Unless I read the fine print, I don't know if I'm getting a type 3 or type 4 oil. And there's a big cost difference between the two. So we can't just buy oil based on what it says on the label. We need to be informed. Synthetic oil can also be thinner, better low temperature viscosity, chemically more stable, offer better protection against engine wear, and it also lasts in the engine longer.
Mr. Brian.
Yes.
Synthetic oil lasts for 5,000 miles?
Yeah.
Is that true?
Yep. I change mine every 5,000 miles. Synthetic oil can last up to 25,000 miles. I change it at 5 because of the contamination issues. So I've done a lot of, I used to have a lot of customers when I had my shop, and we sold a lot of AMSOIL. I'm an AMSOIL dealer, and I still keep the license just because myself and a few friends allows us to buy it wholesale. So I spend the money every year on it. We had customers that not only had 3 oil filters on their car. They had the 1 main oil filter and 2 bypass oil filters. And at 10,000 miles, we pull a sample of oil and send it in for testing to see if the oil needed to be changed because the oil
Yeah,
is
oil change.
25,000. We never saw the oil not need changing. When we got the chemical analysis back, there was always a contaminant in it that required us to change the oil. And that's with 3 oil filters. So I always change mine at 5,000 miles. Some manufacturers are pushing it out to 10,000 miles now or even longer. And where we see an issue is long-term at 125,000 miles, 150,000 miles on those cars. It makes it a warranty okay. And it makes it for the first owner okay. It just doesn't do well long-term. We see other issues, oil consumption issues, leak issues, and so on. So I change it every 5. And right now we have a real competing forces on change the oil. We have the state government spending money telling you not to change your oil. We have public service announcements. We have manufacturers that have pushed oil change intervals out to as long as 7,500 miles or 10,000 miles for non-synthetic oil. And that's because the big push to be green. Okay. The big push to be green is not necessarily good for your car. So we have a conflicting deal. The other thing we have is if I'm a manufacturer and I tell you to run synthetic oil and change every 5,000 miles, the cost of ownership is going to be higher than my competitors is, which means fewer people are going to buy my car because my cost of ownership is higher because I'm telling you to take care of your car, even though it would make it last a lot longer. Which also, let's face it, they want to sell you another car. So they want it to last what? Till it's out of warranty. Lifetime for a vehicle when it comes to fluids or manufacturers are concerned is 100,000 miles. So anything after that is bonus, right? So I change my oil every 5,000 miles because I run synthetic and everything. And yeah, I think the Signature series, and I don't run the Signature in most of my stuff, Paul. I think I have to check. I think I'm paying 11 to 13 a quart for the Signature, but that's a 25,000 mile oil. I usually buy the OE boosted, which is a 12,000 mile oil, and that's what I run in my normal cars. And I change it at 5K. So, and that gets down to $6 or $7 a bottle, which isn't bad.
Mr. Brian?
Yeah.
Would you run the Amsoil transmission fluid?
Yep, I run Amsoil transmission fluid in my vehicles. I run it in my compressor. I use it all kind. Amsoil grease I've used. All that stuff. I mean, it definitely.
How good is it for the 20?
It's good. Actually, my true story. My automatic in my 2012 had an issue with the torque converter flare, and it was documented. The manufacturer extended the warranty to 150,000 miles. I already did the reprogramming in the computer, but it wouldn't act up enough I could get it fixed under warranty. I do it like once every 2 weeks. At 150,000 miles, I drained the factory oil out, put in 3 quarts of the Amsoil World Service, which is what I'm supposed to use in my Toyota. It hasn't done it in the last 45,000 miles. It fixed the problem.
Damn.
So,
you got lucky then.
So I run it in all my differentials. Anytime I rebuild differentials for people, I put synthetic oil in as a technician. I don't even give them a choice because if something's just a little bit off, then it's going to give me a little bit of pad, a little bit of benefit. And I see here, Paul says I have it on my 2000 Toyota on the power steering. Yeah, I mean, they make some really good products. And like I said, so I mean, I'm not here to sell you anything. Amsoil does a lot of testing on their stuff. And a lot of those tests are available on their website, and they're friction wear tests. They'll run engines. I mean, I run Amsoil for my mix oil for my lawn equipment. I run
which transmission oil I can use for a manual if I want to go?
They have a manual transmission oil.
What's the name of it?
Amsoil, AMSOIL. You can go look at their website and see stuff.
I know, but no, the bottle on the manual fluid.
You have to look it up by vehicle. It'll tell you which one you need.
Oh, all right then. Thank you, Brian.
So you can change it with any like I can put it in my Civic if I wanted.
Yeah, like I said, it'll tell you if you shouldn't use it in something. They're real good about that. And you can also, I used to be able to call them also and ask them.
Cool.
Yeah, Amsoil is still a privately held company. They're not a, on the stock market, driven, how can we offshore and make the most money stuff. So, like I said, there's other companies out there. I'm real happy with the Amsoil. I've run the stuff for 20 years and real good. And I see here, if you buy more than $50 worth, membership is waived. And that's, I think, on the premier. Yeah, that's on the basic membership. And like I said, I'm a dealer, so I get a better price on it. And I think what I just pay for the dealership, I think it's $40 a year or something. But I get enough rebates that it covers it, because we buy a couple $1,000s worth of oil a year. Because I have a friend of mine shop and that. So it.
Mr. Brian,
Yeah.
I have a question. Does the number of octane when you get a gas really does make a difference?
I'm sorry, what?
The number of octane when you get a fuel when
The amount of octane in the fuel, does it make a difference? Yes,
Yes.
it can. Absolutely. And we're going to save that for our fuel discussion, because that usually gets into a half-hour plus conversation.
Okay.
Is this
But
the
I will cover it, I promise. Yes,
is the
Amanda.
AMS oil the type that you use at the school too?
What's that?
The AMS oil, is that what you use at the school as well?
That's what I use on my car.
Oh, okay.
Yeah, I see Paul's holding up a catalog. I see he gets the Amsoil magazine there. I got one. And like I said, the article that is on the discussion is off of Amsoil. So they do a lot of laboratory testing. They're an impressive company.
Mr. Brian?
Yeah.
The type 3 and type 4, it should be here in the bottle.
Yeah.
Yes, I have a one quarter here in my hand, and I only see Gen 2, but it doesn't say what type.
Yeah, let me get to the sticker and we'll see and I'll show you where it is.
Oh, you got a sticker there.
So viscosity refers to the thickness of oil or fluidity of the oil. Simple sample of oil heated to a certain point. Heated oil then allowed to flow out of a very precise hole. The length of time it takes to flow determines the viscosity rating. The faster it flows, the lower the rating. And so here we can see a high viscosity versus a low viscosity. Don't let the color confuse you as much as here is how fast it's flowing. So thinner oil flows more easily, reducing drag, increasing fuel economy, which is why we're going thinner and thinner oils. So we now have a 0 W8 oil that's out there. So oil thin out when heated and thickened when cooled. Good engine oil must be reasonably thin for cold starts and thick at high temperature. So the viscosity index measures the oil's ability to resist changes in viscosity with changing temperature. So we're making it act different than it wants to normally. And that's because it contains special hydrocarbon molecules known as polymers. The polymers make the oil thinner when cold and thicker when hot. So it allows it to act the opposite of how it wants to act. Meet viscosity performance requirements of 2 or more SAE grades. So we see here 0W16, 0W20, or 10W30, or 20W50, just to name a few. So the higher the number, the thicker the oil. So it used to be 0 weight 20, 0 weight 16. And that was a winter rating. So when we take the SP2 for Valvoline, they're calling it, and the book does also call it a winter. So 0 winter 16, that's not what it originally was. That's what it evolved into. Unfortunately, like a lot of things, sometimes when people forget what it originally was, and then something catches on, and now that's what it is. So the book's going to say 0 winter 16. It's really 0 weight 16. Really, it's a distinction without a difference. You get the idea. One's a cold rating, the other is a hot rating. So which of the following oil weights is the thinnest?
020.
020. And this is a big deal, because if I have a car that requires 020 and I put in 1040, I'm going to do damage to the engine, because oil is not going to flow correctly through the smaller passages which means I'm not going to be able to dissipate heat correctly, and I'm not going to be able to lubricate correctly. On the other hand, if I took a 020 and put it in a car that requires 2050, again, I would have a problem because the gaps in that engine are big enough for that 2050. When I put that 020 in there, it's going to be too thin. It's not going to seal properly in the bearings. And again, I'm going to damage the engine. So these oil weights are very specific to the particular engine. And this is designed in by the engineers. So in the old days, when a car got older and a little looser, the car might have originally used 1030, and then it might end up using 2050 once it got 100,000 miles or high miles on it. And that was very common on conventional cam-in block engines up into the 90s. So both my F-250 and my Jeep run a thicker oil. They're heavier. They use as trucks. I could get better fuel economy going back to the 1030 they originally wanted. But at 200,000 miles, you know, they're a little sloppy.
Mr. Ryan,
Yeah.
what is viscosity?
Viscosity is the speed in which fluid pours. So the lower the viscosity number, the faster the fluid pours.
That's what you mean? Thicker,
Yeah. Or we think
or
of it as thinner.
thinness?
So you could think the lower the number, the thinner the oil is another way of looking at it. So viscosity.
So which one is better to use, thinner or thicker?
What's that?
Which one is better to use, thicker or thinness?
Depends on the application.
Oh, okay.
There is no one size fits all. So for example, I had a customer with a 1926 Dodge. His differential took 600 weight oil.
So it depends.
It depends.
Where you're
Most
gonna use it.
differentials take somewhere between 75 and 140 weight oil. Much thicker is what we're going to see in a differential.
I have a question.
Yeah.
If say somebody is buying an older vehicle and you don't know what type of oil has been used on it, what would be the best suggestion? Immediately go right to whatever the manufacturer says,
Yep.
or go to synthetic or whatever?
I would, first of all, I'd go to synthetic, period. And then I'd go to the weight that the manufacturer says.
Okay.
You go with synthetic even though it's high mileage already?
Yep.
And though
So
it
hearing-
has been using conventional oil?
Yep. Yeah, because I want to get the most protection I can out for the engine. I want it to last me as long as I can.
It doesn't matter if it's not branded oil,
If it's not what?
branded like the first class oil.
Oh, well, again, what do you mean by first class oil? So I know Costco sells a Kirkland synthetic. And from what I've seen, it's not a bad oil, right? I mean, it's comparable
So they're
to the
all
Valvoline
similar?
synthetic. What's that?
They're all similar, sir?
Similar, but there are differences. And that comes down to the base stock. It comes down to some of the additives they use. So a synthetic oil is always going to be better than a non-synthetic oil. Are all synthetic oils the same? No, they're not. And tests have proven that. When
Yeah,
we look at
because
wear
every
tests,
time
when
I
we
go
look
to
at-
AutoZone, they always give me the synthetic oil.
yeah. And synthetic oil is always better.
So hearing what you just said about the engine becoming loose and stuff on older models, that was probably my brother-in-law's logic when he.
Right. It probably was. And that was good logic 30 years ago. It's not good logic today because we don't build engines the same way.
So, Mr. Ryan, you have to think differently in terms of cars
I changed
in
the fluid.
relation to our health, huh? Because our health, we want to go organic, natural, but for oil, you want to go synthetic.
Right. Absolutely. And again, I think there's a big similarity between our bodies and that. So I could start off when I'm young and eat healthy, or I could eat horribly when I'm young, but it's never too late to start eating healthy.
Mr. Brian.
Yeah.
So yeah, so the only thing here is, I mean, I'm in like in my head, I'm thinking that like an old car, the clearance is actually bigger than the new cars. So that's probably where you have to use conventional, right? Because I mean, if you go to synthetic and you already have a low oil pressure, synthetic's gonna make it worse.
Okay. Let me back you up a second here, Alberto. So you're confusing resistance to friction with being thin. So synthetic oils can be much thinner. They can get much thinner than conventional oil can. But I run a 2050 weight synthetic. I run a 2050 weight synthetic in my Harley. I run a 2050, so you can get thick oils. I get gear oil that's 140 weight in synthetic. So I can get thick oils in synthetic. I can't get zero weight oils in conventional. So synthetic, I can get any of the weights I want. So don't confuse, because you're right. Older vehicles, I might have a clearance of 0.003 of an inch, where a new vehicle, I have a clearance of 1/1000 of an inch. Well, at a clearance of 1/1000 of an inch, I've only got 1/1000 of an inch to put oil in, which means I need to use a thinner oil to get in there. But it also means because there's less clearance, I theoretically I'd get less wear. Because on startup there's less movement. So yeah, you're right. Older cars use thicker oil because of clearances that were not as tight. However, I can still get synthetic in those thicker oils. So don't confuse synthetic with viscosity, two different things. Although if I'm looking at zero weight oils, the only way I can get a zero weight oil is with a synthetic, because I can't get regular conventional dead dinosaur oil to go that thin.
In that case, Mr. Ryan, I mean, let's say just an example, because I mean, sometimes I got people asking me like, oh, I mean, I have let's say a 1991 Toyota Corolla, and it says that I'm supposed to use conventional oil, but the store is actually recommending synthetic. And just an example, just an example. I mean, let's say the car uses 1030, right? Conventional 1030. How can you find a chart where you can use synthetic oil with kind of like same viscosity as 1030 conventional oil?
I think I missed the question because you broke up a little bit. So you're asking about costs? Is that what you're asking?
Oh no. So let's say, right? Let's say you have a 1991 Corolla, and that car uses, just an example, 1030 conventional oil. And if somebody says, hey, you should use synthetic oil on this car, and if you want to change to synthetic, what is it a chart that it will give you like a equivalence of conventional thickness?
Yeah, you're going to use 1030 synthetic.
But there is a difference on the reason why I'm asking is because like for example, like my van uses, the manufacturer says that I'm supposed to use what is it, I think 1030 synthetic for my Chevy 08.
Okay.
And so I noticed that the gauges, when it gets hot, like normal temperature, the pressure drops to like 20 psi. And previously I had a 2002 Chevy Astro, same engine, 4.3. And that one it was asking for conventional oil. So I was using conventional oil, and my pressure was always up to like 40. And when I pretty much switched the oil on my van on the 2008, it's just pretty much staying there at 40 psi with the conventional oil.
Yeah, so that might be the synthetic you're using. Again, there's different qualities with synthetics, but basically you just use the same weight oil because the weight should be the weight. So if it's not acting appropriately, that might be because it's a cheaper synthetic, because I can find synthetic for $6 for $3 a quart. It's not real synthetic. Halfway decent synthetic started around $7 a quart, whether it's Total, the Amsoil OE boosted, it was up around $7 a quart. So one of the things I always hear is that, man, synthetic oil is expensive. I can't afford it. And we can certainly go up in prices of oil. I mean, I can get the Signature Series. If I'm going to run it for 25,000 miles, it's, up to 13 to $18 a quart. But if we do a simple math exercise on a car that holds 4 quarts of oil, now keep in mind, if I'm running conventional oil, non-synthetic, I need to change my oil every 3,000 miles is when I should be changing it. If I'm running synthetic oil, normal synthetic oil, I'm going to change it every 5,000 miles. So in 15,000 miles, if I'm running conventional oil, I've had to do 5 oil changes. If I'm running synthetic, I've only had to do 3 oil changes. So that's 2 less trips in, right? So, you know, conventional oil today is what? $4 a quart? What are you paying? What are we paying a quart now?
Yeah, like $5, somewhere around there.
$5 a quart. So we got $20 in oil. I got an oil filter that's what, $6, $5?
Yep.
So to go $5 on a quart of oil, $1 for a drain plug washer. And if I'm paying someone to do it, actually, I'm not even going to put any labor in here. Let's just do it on materials before I even figure out labor. That's $26. So 26 times 5, that'd be what, $130. If I'm using synthetic oil, $7 a quart times 4 is 28, right? I've still got my $5 filter. I've still got my $1 drain plug washer times 3. That's only $102. So even if I'm doing it myself and not paying labor, obviously I save more when I'm paying labor for someone to do it every time. I'm saving what, $28 and 2 afternoons of my life by running synthetic based on 4 quarts oil. So why wouldn't you run synthetic? You get better protection, you're spending less money, and you're doing less work. To me, it's a no-brainer. When I had my shop, I used to have a chart right up in the waiting room that broke it down costs based on 15,000 miles between running synthetic and running conventional oil.
Yeah, I actually, what I end up doing on my van is actually, you know, like I said, I use the conventional oil, but I add 1 quart of Lucas,
Okay.
the additive, just to, you know, keep it, you know. Right now, I mean, it's been working for a while, but I mean, to mention right now, you know, about like, you know, exchanging the conventional for synthetic. But, you know, I'm like, 2 questions came to my mind. The first one was, is it a chart that it will give me the equivalent, you know, from one, you know, viscosity from one to another? And the other one is like the one that I mentioned before. Where can I find the T3 or? But I mean, you know, I'll just wait. You know, as we go.
Right.
Information on the bottle.
So I'm going to turn on the discussion, which has the article from Amsoil in it. Plus, Paul put the website for Amsoil in here, amsoil.com. They have a whole section on research articles and videos. So they have a lot of stuff where they've done a lot of different tests, everything from snowmobiles to chainsaws to, you know, engines and boats and racing. And so there's probably a lot of stuff there that you'll find interesting, Alberto.
Excuse me, Mr.
Thanks,
Brian.
Ryan.
Yeah.
So Alberto had a 91 Corolla and he was going from conventional to synthetic oil.
Right.
But the question in my mind, and that always used to come up with us, is that when you drain the oil, you're not really draining 100% of the oil out of the system, right? So you have some percentage that's still there. If now you add a synthetic oil to that mix, now you're really combining synthetic and conventional oil.
Correct.
And at one time we were told that's a no-no, that you can never combine those two. And if you went to synthetic, you can never go back. Now this may be in the way back machine, but
it is in the way back machine. You remind me of the early 80s. Yes. Early 80s and mid 80s. That was the thought. There was a lot of people that wrote that. If you put synthetic in your engine, you ruined it. They weren't compatible. You could never go back. A company called Mobil came out with a synthetic oil called Mobil One. And they really promoted, I happened to work for Mobil at the time. They really promoted the fact that, yeah, you can run, you can mix it, you can do anything with it, it's fine. They did a lot to dispel that, you know, that thought process. But yeah, that was early, and that's something that I think is still goes to the another one is if you put synthetic oil in an old car, all the seals are going to fail and it's going to leak everywhere.
I've heard that one too.
What's that?
We heard that one too.
Yes.
It's in the book too.
Yeah. So again, not true. I usually don't use an oil extractor. I just open the drain plug. My experience is oil extractors don't tend to get everything you want, even though you think they would. They would. And I know, and to be fair, Mercedes, if you go to the Mercedes dealer, they're using an oil extractor and not pulling the pan at the dealer. So there are some places that are doing that. I've also found the oil extractor takes so long, I might as well drain it underneath and do it the old fashioned way most of the time. The mixing you're getting, which is going to be about a half a quart of oil, it really doesn't seem to be an issue. And obviously you're changing, again and again every 5,000 miles. I have a friend of mine who paid $200 for a little Toyota Corolla, 190K on it. And he did some repairs on it, not in the engine, but on other stuff, and converted it to synthetic. He put another 100,000 miles on that car running synthetic, and still no real catastrophic oil leaks, no catastrophic problems, anything else. Just a great little car for him. So there's an example of taking an old car, and at the time it was probably it would have been over 20 years old at that time when he got it, and right around 20 years old, and converted synthetic and has had great use out of it with no side effects. And like I said, I run synthetic and everything.
So what I'm hearing is basically everything we were told about conversion to synthetic, going back and forth, mixing the two, was just simply all wrong.
Yeah, it's pretty much wrong.
Good thing I'm taking the class.
Yeah. And why would you go back from synthetic to conventional anyways? Because it's more expensive, which I just showed you, and it's not as good of oil. That being said, if I'm in the middle of the desert and I don't have a synthetic and my car needs oil, could I put a quart of regular in? Yeah.
Thank you. This clears up a lot.
Good. Well, that's the whole reason why we go to school, is to try to clear stuff up. And there is just, unfortunately, the thing about auto is everyone's an expert, and half of what we know is wrong. And I run into that at all levels. I enjoy doing some of the classes I do where I've done a lot of research in, where I built a class, is I got people that are instructors or people that have been doing it 20, 30, 40 years. And they want to, kind of pick the, no, you're wrong because this is what I was taught. And I got to walk through the process and prove that, no, you were taught wrong 40 years ago and you've hung on to it all this time. And so there is a lot of stuff like that in automotive. And there's new things like that being perpetuated today. And that's why a lot of times, and we'll see this when we get into fuel systems and some of these other things, where I kind of dispel some of the stuff that's in the book and go, well, that's really not technically right. A lot of people think that, but it's not correct. So it is constantly, because I'd heard all those things, Rob.
Yeah, unfortunately, we heard them and believed them.
Yeah. Well, I believed a lot of those things too, until I found out they weren't true. So certifying bodies, three most common we see are API and SAE and the ILSAC. So these are different rating companies for oil. We also may have JASO, which is a Japanese company. OEMs may have their own stuff. So what we find is we might have an oil that meets a certain API standard, but doesn't meet the manufacturer standard. So that is where we run into some interesting issues. So here, API, Automotive Petroleum Institute, any oil we buy in this country is going to have this, sets the minimum performance standards for lubricants, has two-part classification, service class and service standard. So the API service class is marked into two categories, either S or C. So S is for spark ignition, C is for compression ignition. The only vehicles that use compression ignition are diesel. So you might as well say C equals diesel. Rarely do we see an oil today that is still certified for both S and C, but there is still some. So I've been into quick lube places where the only oil they stock isn't rated for diesels, and they're changing oil in diesels all day long. I mean, they're putting the wrong oil in everyone's car. API symbol is located on the back of the bottle. So here I see API service SN/GF-5. So that GF-5 has to do with the classification. And I can't remember what the GF means right off the top of my head. I know the book has it in it, but the 5 is the group. So in this case, the 5 is a fully synthetic PAO group. Going back to your question, Alberto, about where is it on the bottle? So if it was a something -4, that would tell me that, yeah, it says synthetic on the bottle, but it's not a real synthetic. If it's a -5, then it's a real synthetic. And it breaks down the different levels as far as how refined it is. So I can buy one weight oil, but if it's a lower number, guess what? It's not as good. So there's a way to kind of peek behind. What is the rating? In this case, we saw SN, which was the newest. They just came out with a new one. So I got to update these charts because I just got a thing on it in the last couple of months. And this chart I didn't make. I cut and pasted it. So I'm going to have to make a whole new chart because it's no longer the most current. So here is a chart of our spark ignition engine oils. And you go from SA, old engines, and SB, which you could still buy when I was younger. And then you had SC, which was very common, SD, and SE, and SF. So when I first came into business, SE was the newest oil we had.
Is it Brian?
Yeah.
So it says right here. Let me see. This is API standards, but it has like a lot of.
Move it up a little bit. Let me see the circle. Move up a little. Move the up a little bit more. I want to try to see what it says. I can't quite read the circle there. Yeah, it doesn't have a number, does it? It just has the letter. Which oil is that? Is that Mobile One?
No, that's STP.
Oh, STP. Okay. Yeah, see, it meets the, if you hold it up, see where it says the Dexos there? So Dexos in green, the 2 Dexos, that's GM's newest oil rating. So we had regular Dexos, and this is 2 Dexos. So there's a lot of oils that might be 020, but not meets Dexos specification. So GM, BMW, Mercedes, Volkswagen, quite a few manufacturers have a specific specification on top of the API rating. So you might buy an oil that has the right API rating, but it doesn't have the rating for that manufacturer's engine. You see how complicated this gets? So that's what you were saying, Christopher G, they're all the same. Then you guys say, well, they do the same thing. Yes, they do the same thing. They do it differently. They have different pieces involved. So on campus, when we've done oil changes, I've had students show up, and when you do an oil change in my class, I require you to have a new filter, a new drain plug washer, and the oil. Before that car gets up on the rack and gets taken apart, I verify you got the right oil. So there's the AMSOIL boosted. That's what I run right there. And because it's a quality price value thing. And so that's what I run in my wife's car and my car. So it, which is interesting. Paul, I think this is the first class I've been in where I had someone else who had AMSOIL. A lot of times people, AMSOIL, I've never heard of it. So I'm getting a kick out of this. So we can see here on the chart that with gasoline engines, as engine technology changed and emission requirements changed, thanks, Paul, we had to come up with new oils, and these new oils have different additive packages, different requirements. So, even though I have a 1974 car, I'm not running SE oil, right? I'm running something newer. So as I come up here for SH, which is the last of the obsoletes, 96 and older engines, obsoleted. And then SJ, we still can find some of SL, SM, and SN. Now, if you notice, The SN was introduced, provides high temperature deposit protection, and now we have a new oil that just came out, which is which I think is SO. I need to double check. I think it was SO. I can't run SN oil in my 95, in my 87, in my 74, in my 80. I can't run it in my old stuff. The reason being is that SN oil is designed for a low friction cam. So when we first went to SN oil, you saw all this stuff, and even SM, we saw this some, where people were selling a lot of zinc additives and other things for these older engines to protect the camshafts. So now, if I buy oil, like when I buy oil for my older vehicles, I buy oil that's specifically designed for older vehicles with camshafts with flat lifters, so I don't have that wear. And that's normally going to be an SL or an SM rating. It won't be an SN rating. So we see a lot of SL oils out there still. A lot of times those are racing oils. You see racing on it. Christopher, that might be your high mileage oil, might have that SL rating instead of an SN rating. So they're doing that because older car, right? We're marketing to these more antique, to these older cars. So oil is not oil, it's continually evolved. So our first tier is our API rating. Our second tier, so we got oil weight, oil rating, and then does the manufacturer have a specific rating that they require to be in the oils? Diesel has a similar chart, and diesel's constantly evolving. Diesel also just came out with a new one, I think, if I remember correctly. And so we see old CA, light duty engines, 40s and 50s, CB, CC, you can see the evolution, 61, CD, which we used forever, which was introduced in 55. And then we didn't get into oil to what? 1987. Then 94, 95, 98. We got to the CH in 98, which is our current emissions. Then we got CI and then CJ. So you see where this has really rapidly changed in the last 30 years, 20 years even, over 20 years for diesel, where we saw a lot of the change on gasoline happened what? In the 60s to 90, that range. Look at how many different changes we had in that 20-year period. Then we kind of settled down. Well, between 67 and 96 or 2001, that's when we did tons of emission changes. We did a lot of engine technology changes. We really went after gasoline engines in design to try to get them to run cleaner. We left diesels alone. With diesels, we did a lot of changes starting in 94, but really ramping up in 98 to current in diesel engine technology and diesel emission technology. So you see where the oils have really had to respond to that. So if I'm running a diesel, like in my tractor, I run a diesel oil. I'm not going to run my diesel oil in my gasoline powered vehicle, even though the range of the synthetic I run is really good. I actually run a 540 synthetic in my tractor, which gives it great protection. It's a Euro spec oil, and it gives it great protection.
Does oil have a shelf life?
Not really. Once it's refined and it's in the bottle, it's good. It's not going to break down and go away like gasoline does.
What about after you take it out of the bottle?
What's that?
What about after it comes out of the bottle? You put it in the car, you only drive 1,000 miles a year. Do you wait 3 years?
That's a great question. And here you got a couple different schools of thought. So it probably comes down to what kind of oil you're using. If you're using conventional oil, probably you're going to change it every year. And certainly that's always recommended to change it once a year minimum. One of the big issues we have is moisture getting in the oil and contaminating it. So it kind of depends how it looks. I can tell you, I don't change my oil every year on my cars that don't get much driving. I'm in the 3-year range, sometimes even longer. But I check and see what the oil looks like at the same token. But you can have oil that's 3 years old and it's black, even though it's only got 1,000 miles on it, because it's just full of contaminants.
Thank you.
So yeah, I mean, I'm not made of bucks. I'm not dumping out good synthetic oil that I know the oil's good, just because it's been in the car for a year. But it does definitely wear differently in a car than it is in the bottle on the shelf. And a lot of
Now,
that's
when you're
moisture.
when you're ch- sorry, when you're changing the oil, and you haven't driven that much, well, like you say, you only do it once a year. Are you doing the filter at the same time, or are you doing filter at different intervals?
No, I always do the filter with the oil. And so I always change the filter with the oil every time. So no ifs, ands, or buts there. And then we'll pull that down. So I'll go, I run good quality synthetic oil. I'll go a couple of years on my vehicles that hardly get driven.
Mr. Brian,
Yeah.
so you will say that, because, even on the sticker, it says, like for conventional, it says 3,000 miles for 3 months. So that's a lie? Pretty much the time that they give you?
No, 3 months. If you know what, yeah. So that's really designed for people that are driving the car every day. You'll hear people say, hey, you should change it every 6 months with conventional oil, even if you're not driving it. Really, if you're not driving it, once a year is fine. Again, kind of take a look at the stuff to go back. And again, what are you doing with it by not driving it? Is it sitting there, or does it get started up and pulled out of the garage to get washed every Saturday and pulled back in? Right? That's hard mileage. You start it up, the thing never warms up. You've got a bunch of fuel wash in it, and you got a bunch of moisture in it. You start it up, move it 30 feet and shut it off. Start it up, move it 30 feet and shut it off. There's no harder miles period than that. That's about as hard a miles as you can put on an engine. So even though you haven't put any miles on the odometer, you've really done a lot of abuse on the oil. So it kind of depends. On the other hand, my truck sits 2 or 3 months at a time, and then it gets started up and driven. I'm fine going 3 years on that because it's not getting constantly moved. It's able to go park, sit, it's garaged. And again, I look at it, I look at the, what the oil looks like, and how dirty does it look? We know that oil traps contaminants. So if I can't see it through anymore, hello, it's full of contaminants.
Yeah.
Now, diesels are obviously the exception because diesel oil is designed differently, and it's going to turn black as soon as you put it in. That's normal.
So, Mr. Brian, the cars the cars that have like reminders for oil change, is it really that smart to know when you should really get that oil changed, depending on how many miles you have and how long you've had the car?
Right. Great question. So we have a couple of different kinds of reminders. And I'm getting a little ahead because I do talk about them a little bit later in the PowerPoint, which we'll get to tomorrow. But we have 2 kinds of reminders. One is mileage-based service. You go 5,000 miles, the light comes on, change oil. And I'm just using 5,000 miles as a random number. The other is condition-based service. So based on how you drive the car, it may tell you to get your oil changed at 4,000 miles or at 10,000 miles. And that's condition-based service, which many manufacturers have gone to. And we see that condition-based service on some European cars get to the 15, 18,000 mile mark. Now, those are synthetic vehicles that use synthetic and so on. What I can tell you is, being in industry, we see a lot of issues on high mileage vehicles. And by high mileage, I mean 70, 80,000 miles. So not really what we think of high mileage, since 125 is average, where these vehicles have issues that vehicles that had the oil changed regularly do not have. So a couple of things happen. First of all, with the condition-based service, all cars use oil. So how much oil did your car use, and are you checking it? So if you're checking your oil and adding as you need to, that's one thing. Most people don't check the oil. They figure it's good. I'll come in for service. So we see this a lot on European cars, BMWs and other ones. They drive it till the light comes on and bring it up for service. Well, if I start with 7 quarts and I've gone 7,000 miles and I now only have 3.5 quarts of oil in there, I've used half my oil, which means I'm trying to cool the engine and lubricate the engine with half the volume of oil. And the big thing there is cooling. So now we start getting deposits in the oil rings and the engine starts using oil. Also, another thing oil does is oil lubricates the seals, which helps keep me from leaking. So if you maintain the oil level and keep an eye on that, the condition-based service does work. But you also got to look at why they have the condition-based service. You know, the condition-based service is there is because it lowers the carbon footprint that the manufacturers are getting approved on. And so they're trying to use the least amount of oil as possible. And that's why we see that. So it's really not for your benefit. It's for the political benefits of why we do this condition-based service. And, you know, we see a lot of cars and a lot of very expensive cars that are really messed up by 100, 125,000 miles because of that condition-based service. Now, some manufacturers do it a lot better than others. Honda does it better than a lot of the Europeans do because Honda doesn't let it go as high. It caps it out higher. But we do still see a difference on customers, even with Hondas, between using the condition-based service and the changing it just a regular 5,000 mile interval with synthetic or 3,000 with conventional. And where we see that is in things like oil leaks. You know, things you wouldn't think of. You know, we look at the front seal and the rear seal on the crankshaft. Well, those are expensive to replace. Oil health directly relates to how long those seals and gaskets last. And so we'll see cars that haven't been maintained leaking oil from everywhere. And the same year, make, and model on a car that has been maintained with the same mileage or higher mileage with no oil leaks. Now, does that mean that you can't get an oil leak if you maintain your vehicle? No, of course not. I'm not saying that. But what I am saying is that there is a real direct relationship between running the oil too long or running oil low and, you know, other problems in the vehicle. And the other issue we have is that once my car starts running low on oil, and once I get gum in those oil rings, my car now uses more oil. And so it becomes a worse and worse problem. And then we start having customers with these cars coming in and their red oil lights on because there's nothing on the stick. Well, as soon as the red oil light comes on, that's when there's no oil pressure. We're doing damage on the bearings. We're doing those things. And it would have been all preventable by just doing the regular maintenance. Oil changes are so cheap. It's the cheapest thing you can do to make a car last a long time. And, you know, gee, could I go 6,000 miles or 7,000 miles instead of 5? Maybe. Could I go 10? Maybe. But really, over the life of the vehicle, is it worth the risk? Do I want to find out I was wrong to the tune of $4,000?
Is the condition thing what's illustrated in like the owner's manual where they say like, you know, severe and normal driving? Is that?
Well, we have severe and normal driving, and I have that on the lab, and I'll go over severe and normal tomorrow. And what you'll find out is if you drive in Southern California, you drive severe driving. Okay. So if you drive in San Diego County, you qualify for severe driving, even though no one thinks they do. And it's things like if you take trips less than 5 miles, if you take trips more than 20 miles, if you drive when it's more than 80 degrees out, if you do excessive idling or stop driving, if you do any towing, I mean, dusty conditions. It doesn't rain here for 6 months. Hello, we're in a dusty condition. You can't drive on the freeway without doing stop driving. Everyone does trips less than 5 miles. I mean, if you go down the list, and the list varies slightly by manufacturer, but I guarantee you everyone in this room does severe driving. So, you know, go ahead, Dale.
No, I was gonna say, because our Honda Odyssey, I like the oil reminder, change oil, because it tells you once you've changed your oil, the status will say 100%. So then when it lowers to about 15%, it will remind you to have the oil change. So is that considered like condition based, like you were
Yeah,
saying?
Honda uses a condition base, and that 100% you get is because the person who changes the oil reset it for you.
Right, right. And so I like that better than, because at any point in time, you can tell whether it's close to, to 15% or whatever. But unlike other cars, they don't have that. Is that true?
Yeah, a lot of
Other-
cars don't. Like my Toyota just has a light that comes on about 400 miles before it's due for the oil change, telling me every time I start it, it stays on a little bit, letting me know, hey, we're getting close to an oil change. And it's set for every 5,000 miles. So every 5,000 miles, it does that. Your Honda is condition based. So, doing a lot of start stopping, it's going to want you to change the oil sooner than if you're driving on the highway. If you're towing, because it's actually talking to the engine computer and looking at certain data parameters and how fast the car's driving, how many hours the engine's been run. There's a lot of factors that go in. Honda actually does a pretty good job. And one of the reasons for that is Honda doesn't let it go as long as the European manufacturers do. But in Europe, they are really, really pushing for those fluids to stay in the vehicles close to forever. So that's one reason why we see that on European vehicles. So Honda does do a better job than that, in my opinion, than the Europeans do.
Okay, because I read on the manual also, in the beginning, where it says, it will come on, the reminder will come on at 15%, but you don't have to go right away
Right.
and have the oil change. So I usually wait until it's close to about 0. Is that good or bad?
Yeah, it's probably not good, but it's not necessarily bad.
Okay. Just didn't want to spend right away,
I know, that extra couple of miles.
Okay, thank you so much.
Oh, you bet. An API rating of SN indicates the oil can be used in which of the following types of engine?
Is it number 4?
It is number 4.
Both 1 and 3.
Because I said diesel is the only combustion ignition engine. So therefore, natural gas has to be spark ignition.
Yep.
So even though I didn't talk about natural gas, I did tell you that diesel is the only combustion ignition fuel. Therefore, everything else is spark ignition. Pretty tricky, huh? Manufacturers may have additional specifications on top of the API rating for engine oil. True or false?
True.
True. So many manufacturers state oil does not have to be changed before 7,500 miles or every 6 months under normal conditions. Definition of normal condition varies greatly. Newer vehicles may have an oil life monitor like you're talking about, Dell. Oil changed at least every 3,000 miles or 3 months with conventional oil. Engines operated under, and this is right out of the manufacturer. So even though they're talking 7,500 miles, as soon as I get to severe conditions, we're down to 3,000 miles. So this is operating in dusty or dirty conditions, poor mechanical conditions, engines used for short trips, cold weather, hot weather. Turbocharged and supercharged engines also normally require 3,000 mile oil changes because of all the heat generated. And even the best oil is useless unless it can reach the engine's moving parts. So the job of the lubrication system is to get oil to the moving parts of the engine. So on a friction bearing system, the oil is used between what two components in order to reduce friction?
I'm just guessing any of the above.
It is not any of the above.
Number 2.
Okay,
That's in
so let's
bearing.
look at this.
Number 2.
Number 3, bearing and shaft.
Okay.
Because the shaft is what's rotating, the bearing's not rotating.
Yep.
So we put oil between those two things. The bearing is attached to the housing and doesn't move. So there's no reason to put lubrication there. And if the housing's touching the shaft, we no longer have a bearing and we have a real problem.
So the answer is bearing and shaft.
The answer is number 3, bearing and shaft. So, all right, so we're going to get into our lubrication system components next and start with identifying.
Mr. Ryan, what do you call the technicians in B and C and A?
I'm sorry, what?
Oh no, yesterday what did you say about the technicians?
Oh, about number 1. Number 1 is where the bearing goes against the housing.
Not the bearing. What we talked about yesterday on the service line when you work as a technician, the duties on each technician.
That wasn't yesterday. It was quite a while ago. We talked about A techs and B techs and C techs.
Yeah, that one. Yeah, I kind of forgot the name of each one. Can you re-say it?
Well, an A tech is your most experienced tech who can do diagnostics, can do everything. B tech is normally a technician who's experienced at replacing parts, but not at diagnostics. And a C tech is your entry level technician.
Oh, no, it's because it's asking on the CDX. It's the exact name. I can't just put.
I don't know. I don't know right off.
All right.
So anyhow, so we're going to get into talking about our lubrication system. I'm also going to pull up in all data and we'll look up some severe service for some of these vehicles so we can kind of see some of the qualification. We'll see that really if we're in California, we're severe service. I'm not going to turn on the lab for lubrication until tomorrow. I will get the discussion turned on today. And I think we're at a great stopping point today. Great class, guys.
So for the homework. Thank you so much. Have a good one, everybody, and you too.
Hey, you bet. Oil's always fun, and coolant's fun to talk about too. Doing coolant on Monday. So these are things that everyone can relate to. Everyone's had to buy. Everyone's in the car, so it's a chance for me to dispel some of these myths.
That's great. Looking forward to it.
All righty, everybody. You have a great rest of your day.